Okay, so let's start with the first one here. We know the rectangular coordinates are -3, comma 3. So let's just start off with, how about we start off with some straight lines? Let's see here. All right. Okay, so -3, comma 3. So I'm going to go back here, -3. I'm going to go up 3, 1, 2, 3. Okay. So I'm talking about this point right here. In order to figure out my r and theta, I need to know what is the distance. So r is going to be the distance between the point and the origin. And then theta is going to be the angle. Okay, so what is this distance? Well, first let me just say one. Let me just say one thing, which is we could use our relations as from before, which is r squared equals x squared plus y squared, and tangent of theta is equal to y over x. Okay, and so now we would say we know x is equal to -3 and y is equal to 3. So r squared must be 9 plus, what is 3 squared? 9, which is 18. So r is equal to plus or minus square root of 18. It's so tempting to think of r as radius, and therefore it has to always be positive. But remember that we can't actually have a negative. We can have a negative value for r. So just for now, I'm going to leave it at r squared equals 18. And then for theta, tangent of theta is apparently equal to 3 over -3, which is equal to -1. So if tangent of theta is equal to -1, we can use like the unit circle to say when is tangent equal to 1 or -1. Okay, so tangent is -1 when, let's see here, theta is 3 pi over 4, or theta could be negative pi over 4, or any, right, or theta could be 3 pi over 4 plus 2 pi, right, or negative pi over 4 plus 2 pi, right, you get it. So what we need is essentially 3 pi over 4 plus 2 pi k. So let's just go ahead and write that down. 3 pi over 4 plus 2 pi k. 3 pi over 4 plus 2 pi k. And then with the r, as we said before, r could be plus or minus square root of 18. The square root of 18 is going to be, that's 9 times 2, 3 root 2. Okay, so we can get that this r is equal to 3 root 2, and the theta we can just use theta equals 3 pi over 4. So we could take 3 pi over 4. So that can be one answer. R is 3 root 2, and theta is 3 pi over 4. Now to get a value with the negative r, we need to think about what would we need to do with r, right? We would have to look at this point down here. Now if we had, so that would be, what would that be? That looks like negative pi over 4. So what if we were to say we want negative pi over 4, and we want r to be negative 3 root 2. I think that'll work. So go out 3 root 2. Sorry, go out 3 root 2. Right, so r is 3 root 2. And we want to go down pi over 4, right? And then flip it. And that would get us back. That would get us back here. So that'll work. So we could also have negative 3 root 2, comma, negative pi over 4. Now we could also have, let's, go ahead and throw this in here. We could have 3 root 2, and instead of pi over 4, we could have pi over 4, sorry, 3 pi over 4 plus 2 pi, right, which would be 8, which would be 11 pi over 4. So that would also work. So if you notice, there are infinitely many ways, to describe a rectangular coordinate using polar coordinates, because you have infinitely many thetas, right, that correspond to the same point. So just like theta is periodic, angles are periodic, right? So theta is going to be the same location as theta plus 2 pi, the same as theta minus 2 pi, same as theta plus 4 pi, any integer multiple of 2 pi. That's going to give us multiplicity in the r theta coordinate space, right? Whereas with rectangular coordinates, if you have polar coordinate, you can only represent it one way as in rectangular coordinates. But if you are given rectangular coordinates, you can express that point infinitely many ways using polar coordinates. Okay, now what about 0, comma, negative 2? Okay, so let's look at 0, comma, negative 2. Let me just add a new page. Add a page below. So 0, comma, negative 2. What are we doing here? Oh, I very rarely get to use my squared paper. So let's go ahead and use my squared paper. So I've got 0, comma, negative 2. I'm already messing up even though I've been given some structure to follow. So this is 0, comma, negative 2 in polar coordinates. So this, sorry, not polar, this is opposite, rectangular. And in terms of Cartesian, let's do Cartesian or polar coordinates with my pink. So I could say, what is my distance to the origin? That distance is going to be 2. So I could say go out to 2, right? So go out to 2 and go down pi over 4. So I'm going to say 2, comma, negative pi over 4. I could also say go out 2 and go up 3 pi, or what is this? Not negative, it should be negative pi over 2. Sorry, negative pi over 2. So I could also say let's go out to 2 and you have theta equal 3 pi over 2. Gives me the same location. I could also say go out to 2, go up pi over 2, and then flip. So that would be negative 2, comma, pi over 2. And I'm good to go. I could say, now that I think about it, I could say go out to 2, go down negative 3 pi over 2, and then flip. So it could be negative 2, comma, negative 3 pi over 2. So we've got plenty of options there. So that's one with r is positive and one with r is negative. Or you could use the other two. Infinitely many answers. Okay, our last one is 3, comma, 4. Okay, so for 3, comma, 4, let's see. So over 3 and up 4. So I'm going to, so this is going to be 2, 4, 6, 2, 4. So this is rectangular. Okay, for me, the easiest thing to do is to figure out r, because that's just the distance to the origin. So what is my r? R is going to be, I'm going to take the square root of, now if this is 3 and this is 4, 3 squared plus 4 squared, Is that 16 plus 9, 25? So r is equal to 5. Duh! 3, 4, 5, right? Isn't that a special right triangle? Okay, so r is equal to 5. And now, what is the value of theta? Okay, so to get that theta, do you see I need this theta? I need to know what is this theta. Now, tangent of theta is 4 over 3. Tangent of theta is 4 over 3. So, theta is arctan of 4/3. How about that? So, my polar coordinates are going to be 5, comma, arctan of 4/3. So I can do that. Or I could go, I could so down here, now what would this theta be? This would be whatever that theta is plus pi over 2. Right, so from here to here is pi over 2. So I'm going to have as my theta pi over 2 plus arctan of 4/3. And then I can use -5 as my r. All right, good times, good times.